Hello grade 11s. I thought it wise to go through the answers to the questions on the homework that I gave you last week, as well as the few questions I gave you to do this week. Because I never got to the content that I've discussed in the videos, I asked you to do exercise 3, number 1, 2 and 3, but just the A and the B part. So I'd appreciate it if you will do the C part after the discussion here. So in question 1, 2 and 3, you had to draw a labeled force diagram and identify the type of friction nor force that was acting on the object. And then the part you haven't done is to give the equation necessary to calculate the frictional force. If there is enough information, calculate the magnitude of the frictional force. So that part would be the homework. Right, so question 1 says, Norco tries to push a heavy crate, mass 50 kilograms, across a carpet with a force of 60 newtons. The crate does not move. So I assume that this crate is on a flat surface, and we've got the crate with a mass of 50 kilograms. There is a pushing force of 16 newtons. They did not say whether it's to the right or to the left, so you could have the F push. For a force diagram, the arrow of the pushing force must be on the object. The weight of the object goes from the center of the object, that is the gravitational force, and because the object is placed on a surface, there will be a normal force, and the friction acting on the object would be a static friction, and it would be, if the pushing force is to the right, the static friction will be to the left. To combine these forces in a free body diagram, that was not part of the question, but we need to practice to do that, because the Fg and the Fn are the only vertical forces. They should be equal to each other, and the F applied, now with a free body diagram, all the forces should be tied by their tails, and the friction, because the object is not moving, the static friction should be equal to the pushing force. I see my arrows don't look the same length. Let me just redo that one. So the arrows should be more or less the same length. Okay, so that's number 1, the A and the B part is static friction, and you need to do the C part still. Okay, the same rule applies. If you need to pause the video, please do so in order to give yourself a chance to catch up. Question 2, Norco pushes harder with a force of 70 newtons and the crate is just about to move. So then the static friction would be the maximum static friction. So there's our 50 kilogram object. The weight will be Fg, the normal force will be in equilibrium with the weight. Maybe I should put those values in, and the pushing force now is 70 newtons, and above it was 60 newtons. Here, let me do that. That makes it more fun. So the gravitational force is the mg, which is 60 times 50 times 9.8, and that's 490 newtons, and the normal force would also be 490 newtons, and in this case the static friction would be 60 newtons. So I've got all the information that I need to put the values to all the forces there. Alright, back to number 2. And we still need to indicate the static friction here, and this would be Fs max. So that's the force diagram. The free body diagram would look like this. The weight would not change, so it will still be 490 newtons. The normal force would not change, that would be 490 newtons, and the force of action, the applied force, would be the pushing force. You may call it applied force, that's 70 newtons, and the maximum static friction would be 70 newtons. So question part B is maximum static friction. Question 3. Norco increases the applied force to 85 newtons and the crate moves. Go away. It's 50 kilograms and applied force is 85 newtons. So the applied force would be 85 newtons. Now the friction would be a kinetic friction. And this kinetic friction should be less than the Fs max. So this is a tricky situation where you will need to get the expression or calculate the kinetic friction. There is a weight. Fg remains 490 newtons, and because none of the other forces have a vertical component, the normal force is 490 newtons. This B part to the question is kinetic friction. And you still need to do the C part in both 1, 2 and 3. Just to finish my way of doing this, Fg, Fn, sorry, I'm squashed for space here, not a curly F, Fa, that was 85 newtons, that is 490 newtons, this is 490 newtons, and the friction there would be kinetic friction, and it is less than 85 newtons. Alright, that's number 1, 2 and 3. You can work through those answers. I'm going to end the video here and then make another video for the other questions I gave you to do.